Now let's go on to the second question. We can find that it's very similar to the questions we have dealt with in last homework. So let's go to the question. A. Draw a couple of samples. So we can draw an arbitrary sample, and actually I'm not sure if I was correct, but I think it's what the question asked me to do. Then we have to find the probability of x of t equals 2, and we can easily find that the probability of xt equals 2 equals the probability of n is odd in the interval 0 to t. And so let's make the probability of xt equals 2 equals a1, and we let the probability of xt equals minus 2 equals bn, and that is the probability of n is even in the interval 0 to t. So we can easily see that an plus bn equals 1, and bn minus an equals this, and we can get the answer it equals a to the minus 2 lambda t. So we can get an equals 1/2 times 1 minus a to the minus 2 lambda t, and it's the answer of probability of xt equals 2. And the third question is, let's find the exact value of xt, and the fourth is, let's find the autocorrelation of t1 and t2. According to the definition, we can easily get the answer. The exact value of xt equals 2 times the probability of xt equals 2 plus minus 2 times the probability of xt equals minus 2, and we get the answer is minus 2 times e to the minus 2 lambda t. And the correlation, it equals the exact value of the product of x of t1 and x of t2. It's when x of t1 equals 2 and x of t2 equals 2, or x of t1 equals minus 2 and xt2 equals minus 2. The product of xt1 and t2 equals 4, and otherwise it equals minus 4. And we can rewrite it as it equals 4 times the probability of k is even in the interval t1 to t2 minus the probability of k is odd in the interval t1 to t2. So we can indicate the answer. It's 4 times 1/2 times 1 plus e to the minus 2 lambda t2 minus t1 minus 1/2 times 1 minus e to the minus 2 lambda t2 minus t1. And the answer is 4 times e to the 2 lambda and 4 times e to the minus 2 lambda t2 minus t1. And we can see that it's a function of t1 minus t2, right? But since exact value of xt depends on t, and that is, it's not a constant, so we say that x of t isn't a White-Sands stationary process. Thank you.